Let's look at set points in a little bit more detail. We're still going to stick with the air conditioner theme. And if we look over here at this graph, this is actually essentially what I was drawing on the other page. Set points are an average value, but generally speaking, within that average value, so we might have a set point of 22 degrees, we have what is known as an acceptable range, okay, or a normal range. And that's the range that we can fluctuate around the set point. And therefore, or let me rephrase that, we can fluctuate around the set point, and as long as we're within that normal range, nothing happens. The air conditioner doesn't turn on, the control unit doesn't respond, okay? But once we're outside of that normal range, that's when we would consider homeostasis as being temporarily just nudged in the wrong direction, and that's when we would end up responding to maintain homeostasis within these normal values. And we're going to see ranges like this all the time. For example, if I talk about the normal sodium concentration of the blood, I might give you a value, 135 millimolar per, for example, of sodium ions in the blood. But that's just an average, and that average will be different or might be reported differently depending on your textbook. So one source might say it's 135 millimolar on average. Another source might say that sodium ions are at 132. Or a third source might say it's 140. And those are all correct. And you might be scratching your head, well, how can they all be right? The answer is it depends on the population that we sample. We'll get a chance to talk a little bit more about statistics later on. In fact, it'll be this week. We have a lab dedicated to working a little bit with statistics. And what I want you to understand here is that there's two types of statistics. There's what we call, well, that oversimplifies it, but we have what we call a population average. And that would be, depending on what you decide, that could be the entire population of the world if we wanted to. And it's highly unlikely that we would be able to count all 8 billion or however many human beings we happen to have in the world right now. And so usually what you see reported in textbooks are actually what's called a sample average. So somebody has measured over the course of time, not perhaps 8 billion, but maybe 1 million. And even that sounds a little high, maybe 500,000 or whatever. We happen to do these values, and it depends on where the sample is taken as to which values we might get. We might have, it's a little bit hard to believe and probably not true, but we could theoretically have a different average body temperature for people in South America than we would do in North America. And so that's a little, it's not real, that's a silly example, but it kind of gives you an idea as to how come sometimes you see these different variables in the textbooks and in the scientific papers, and you're like, what is the average resting heart rate of a human being? Is it 72? Is it 74? Is it 70? What is it? And you'll see these different values. Okay, so we'll talk a little bit more about that, but I wanted to make sure you understand that these set points that are often reported will vary based on sample mean, and also just vary on simple time, like when you measure it. Body temperature is a great example. Especially in women, body temperature fluctuates based on the hormones that are present in their blood. And so after a woman ovulates and until menses, when she menstruates, her average body temperature will be a little bit higher than it is prior to ovulation. And so you get these, you can get different values depending on when you measure it. But back to this issue of set points. So we've got this oscillation around a specific variable. The other thing that I want to emphasize is that these things can shift. Body temperature, as I just mentioned, is a great example. And so let me go ahead and use some of this blank space up here and look at that. And again, if I'm going to do a timeline right here, and maybe on the bottom, instead of dealing with hours, I'm dealing with weeks. And we'll just use average body temperature. Of women that are of reproductive age, that are menstruating, okay, what we might see is if we start with her menstrual cycle as being day 0, and we assume that at approximately day 14-ish, okay, is the day she's going to ovulate. So I guess we should change this. Instead of saying days, let's change that, or weeks, let's change this to days. Okay. And if we look then at day 28, and again, this is an average, day 28 of her cycle, she's going to start menses at day 0, and so 28 goes right back to day 0. I don't know that that's spelled right. But if we were to look at her body temperature, what we would see, if this is when she ovulates, we would see a set point here, okay, and then a slight shift in that set point of about 1 degree afterwards. So what happened? Did we lose homeostasis here? No. The set point shifted. And we have shifting set points all of the time. This is just one example that I brought up that I'm mentioning, but we also have things like, let me scribble it in down here, cortisol. Oops, I should say cortisol level up here. And in a 24-hour cycle, so this would be hours, okay, and this is 0, well, approximately, so this would be midnight, and approximately, I guess we'll go 24 hours right back to midnight again, okay, and this would be noon-ish. What we actually see with the cortisol levels is that they are very low, and then they go up during the morning, and then they start to drop, and they might get a little spike at the end of the day. And we repeat this cycle over and over and over again. And you're most awake when your cortisol levels are highest. And we call this a circadian rhythm that occurs with the cortisol level. And there are a number of different things that will experience these shifting set points. At any given time, the set point might be here, or here, or here, or here, or here, or here. Homeostasis is not being lost, the set point is changing. And there are a variety of factors that will go into regulating those set points, and we are still maintaining homeostasis, and so we do not have a pathology. And I want you to understand that, and it's a pretty important concept to understand. Here are some examples of just some physiological variables that would be controlled by homeostatic regulatory mechanisms. And you can see hemoglobin saturation. That just refers to how much oxygen is bound to the hemoglobin. And when we leave the lungs, that saturation in the arterial blood is about 98%. And it's lower in the veins, but that would be our saturation there. And blood oxygen levels, and so forth. You can see each of these things that are going to be regulated. Now let me talk this one, because this is a good example of homeostatic regulation that's kind of fun to play with. This is a average value, but if you were to actually look at this value over time, it's going to spike. You eat, it goes up to 130 or so, and then shortly after, depending on what you eat, and then after it goes back to the regular value, and then you're really hungry, you skipped lunch, and it might drop too low. And these will control responses, and we'll get into some of that when we talk about glucose regulation a little bit later on in the semester. This is another one that we see shift a lot, is blood pressure. In fact, it can shift based on the needs of the body at any given time. Mean arterial blood pressure just refers to the average blood pressure in the arteries at any given time, and if we are exercising, that mean arterial pressure is going to go up. That doesn't mean we've lost homeostasis. It just means that the set point has shifted. And we are doing that. We are shifting these set points to compensate for the needs of the skeletal muscles for more blood flow. And so the more blood pressure we have, the more blood flow we have going to our skeletal muscles. And so we'll get a chance to look at all of these as we go forward in these different systems. But that's one of the reasons why understanding homeostasis and set points and so forth are so important.